Hello everyone. Thanks for joining. So as the topic suggests, right, emerging trends in data engineering with AI. So I will take you through this will be agenda for next 30 minutes and so, and if we have time, we can have answers, question and answers. So we'll start with the data platform architecture, and most of you will be familiar with that. Then we'll go over what are the challenges with the traditional data engineering teams, right? All of us most of you comes from data engineering background, and you must be knowing all those things. And we'll talk about some of the things that we have solved at PharmEasy using AI. And then we'll talk more details about what are the emerging trends. Okay, so I mean, this is the architecture that most of you are familiar, right? Now, on the left-hand side, you have source systems, be it from RDBMS, NoSQL, any file systems. You can have data from your REST APIs, or you can do the event ingestions, right? Be it clickstream events and all. And then in the middle, you'll have what we call it extraction or ingestion layer. I mean, this is our architecture, so somebody maybe put a Kafka or maybe directly load to your data warehouse or something, right? And in between, you will have the transformation layer, right? And you manage through some workflow, let's say Airflow or any other engine that you have somebody, and you do the data cataloging or maybe self-service part of that, right? So, I mean, if you see these architectures, this has been working for ages. Obviously, data warehouse was there from the days. It has changed to new things called BigQuery or something else, right? And many things has come, right? In open source, we have high Presto query engine on top of it. But underlying things are not changing, to be honest, with the AI. The problem that let's talk about few challenges that all of us face when we looked into AI world, right? And how AI is solving that problem of data engineering, right? So I think many of the sessions already happened in the morning, and you must be knowing that there are a lot of product available in the market. But I will not get into any product-specific problems and all, but let's talk about the problems that you see, right? Starting from your sourcing layer, which is the data ingestion layer, right? The problem, most of you see, right, source systems have changed some schema, and it has gone to your analytics team is saying that everything is broken, I am not getting the data log. So obviously there is a data latency on that because the pipeline is broken. It could happen like in between, like if you see my architecture, we have multiple components, right? It could be Maxwell, Debigium, which we use for CDC. There could be a problem in that systems because there could be huge lag or something. If you're using Spark for your loading data log, there also could be some problem in that, right? So your data latency could be a problem because the analytics expects certain point of time the data should go. Same thing can happen in your Kafka layer, like let's say some rebalancing is happening and your data is not right? On the right-hand side, while you're loading the data, let's say we use Apache Hudi, but if you're using any of the Delta Lake format, there could be schema is evolving over the time, and there could be problem in that, right? Now, and most of the times, like we have facing this, like all our data engineers are sitting around the corners to solve these problems. And I will see that, how we have solved this problem. So I just wanted to be more particular on the problem that we are trying to solve. So I mean, whatever I talked, I have just listed, right? We have reactive monitoring when something is caught after, let's say, analytics has, or any other downstream system has complained the data is not available, right? You have manual data quality checks, like from the source to your destination, you have some data quality checks, but they are manually, right? From the time to detections to time to resolution, it takes some time, right? I have working with a big company like Walmart, I have seen that it goes in multiple days to fix those issues. So how do you have a faster issue resolutions, right? Then how do you scale your data platform? Like let's say, I talk example of Walmart and even with my current company, PharmEasy, like let's say new source is being added, right? How quickly you can give the data to your consumers, right? It takes like setting up the pipelines, engineer has to set the pipelines, create those transformations or load the data, right? It takes days. How do you make sure that if new systems are getting added and new pipelines are added, you are able to scale that, right? So these are some of the problems. And then the cost. So last 2 years, I'm working in PharmEasy to reduce the cost of the data that we had. And all of you must be working some way or others to reduce the cost of the pipeline. Like, how do you create this, right? These are some of the learnings that I have put it, and maybe you might have also encountered that. Coming back to, like, obviously the solution is to have proactive monitoring. How do you, like, so what we have done it like monitoring part. So right from your data comes from, let's say, DBGM, Maxwell, to your Kafka, to, let's say, Hoodie data lake or something, and then the consumptions layer can come. We have put all the, I could say, data instrumentation so that you get all the metadata associated with that, right? And then you publish to another Kafka topic, and you have a monitoring alerting based on AI. So AI can detect what are the anomalies on that. Like, let's say, some of the query is running for some, it's a small things, right? Some of the query which is getting the data from some systems is running for longer time. It can alert you that this can, it was working previously also, but AI is going to help you on that. Then we also have like automated data quality management, which basically like you have, let's say some field is null, or some values are not coming up properly. Manually, you set up a rule, and then you go ahead and try to make sure that your rules are, your data is as per the rule, and if there is nothing, then you can show into dashboard. Now, that's one way of looking into it, but ideally, like data drift or any missing value outliers, all these are the problems that ML solves, right? Not only with the Gen AI, but all the problems that we have been looking into, right? You see the patterns of your data. Let's say any data is getting ingested over time, or maybe there is anomalies on those patterns. So we have automated using some of the, what we call it MLDQ, and that has helped us to basically predict what can be future. Not only that, when the issue happens, let's say pipeline is coming, we have some time to react to it. That time only it says that your data is not as per that. Like suddenly the, let's say, volume of data has increased. There will be delay on the data side, so it can alert, and then you can take some level of corrective measures, right? I talked about like one of the problems, like when issue occurs, you take a lot of time to fix it, right? Why it is? Because you have to understand from where the data has come, right? It could be from the source system, your DBGM has some issues, or your Kafka has some issue, or maybe while loading the data has an issue. So what we have built it like end-to-end data lineage. And not only data lineage, there is a lot of tools to build the data lineage, but what we have done it like we have power with AI, which basically gives us what has gone wrong with that, right? It basically gives you like, if some problem has come, let's say it could be your SLMS, or it could be data quality issues, some values are missing, some data is not coming, it basically trace back to that component where is the issue. And it gives us an intelligent view of that. This work is still in progress, but we are able to solve that complete end-to-end using AI. Scalability, right? I talk about like pipeline, it takes a lot of time to create it. Like we have been solving this problem without AI also. Like we can create a self-service drag and drop, and basically you can have that end-to-end data pipeline created within few hours. But with the AI, like with the generative AI, like all this pipeline can be automated using some commands, right? And basically you have agentic frameworks in between which can orchestrate that and create you that. So we have been doing a lot of work on that, like because we work in multiple different companies. We have a group of companies, and each company has their own data needs. So what we're trying to do it like make sure that all the scalability of not only the pipeline, but even let's say you have to elastically scale all the auto scaling of those parameters, then we can configure it. And that will help us in maybe onboarding a pipeline from days to few hours. I can say that because our team has been working on it. Then last but not the least is the cost control, right? As I said, like there's a lot of learning on why the cost has increased in data pipelines, right? Many of you know that we say that distributed like S3 or any other systems like distributed file system is cheap, right? You just say that, but in practically, and at my level, like what I work in the group of companies, our S3 cost is the highest, more than the compute cost. A reason for it is like you don't know what data you are trying to ingest. Like one of the reasons that I will talk about is like there are so many versions of the data that you keep it, right? S3 has something called versioning. So I know that this AI has come up with a lot of features which you can detect and see where is the data is going. Like let's say you have a versioning of the things, you understand whether it's a real data or it is just a copy of the data that you have. And that way, it has really helped us to control some of the cost feature. It has drastically reduced our cost. Like we have been able to, do that by finding some of the. So I'll talk about like all these are, I could say, AI has helped us in powering all these data pipeline in a better way. We are still work in progress on this area, but we have seen tremendous benefit of using all this AI capabilities to make sure that our pipeline are reliable, it works at lower cost, and we deliver to our end customer on right time, right? Now talking about like what are the key trends, right? Which we have been seeing and we have been applying. So I have put few points, and it's still evolving over time. I think some of the session was on this, right? I mean, data pipelines. One of the important part is your metadata, right? Like when I was with Walmart, I was working there on their data cataloging system. And believe me that it was a humongous task. So many data sets coming into picture and cataloging them was a big problems, right? Because let's say you have a table, thousands of tables, thousands of columns, how do you catalog? And make sure that they are accurate, right? Because as your source is being changed, your data, like your underlying metadata will be of no use if you don't update it. Right? So that's the one problem. I think even Google and Microsoft, we have been working with them, like they have their own cataloging engine. But the problem with them also, like, these has not been integrated on that. Some of the open source companies and all those has some power, like where you can use Gen AI to generate your metadata, right? So that your work, your engineers is not just plumbing that cataloging, but it automatically gets generated. Not get only generated, but it get updated also over time so that your metadata is more clean, right? Related to that, like one of the things that we are heavily investing using AI is like self-service analytics, right? Which means like, I'll talk about details about this, but this is one of the area that we have been investing. Like users goes like, to a dashboard and they look into data and they try to, see what is the pattern in the data and then try to get some level of understanding if something is going on. Like it could be a sales dashboard, it could be anything else. What we have powered using Gen AI is like using text-to-SQL is like they can have story with their data, right? I think they can just ask the questions and they can answer those questions in plain English language, right? So that's the one of the, I think, heavy investment from my company on to make sure that business team is not depending on analytics to give them data. Like, they just works on like data, like which is basically they can self-serve, right? Then synthetic data generation is one of the problem. Like, when you start doing your data pipeline, or any other ML training or testing, the problem is that where to get data, right? Your QA environment has very less data, right? Once you get into production, there is a huge problems that start coming up. Say, like I was working with one of the financial companies. Everything was working in QA, but once we deploy into production, everything failed. The reason for it that we don't have the right kind of data that on which we have tested, right? With the generative AI, you can test this diverse set of data, right? Like let's say the problem for us was the skewness in data, right? Like US has more data than India or other companies. So you can create those and simulate your real-time data, not with the actual data, but with the synthetic data. This is one of the area that Gen AI has been really helping us. Then obviously, like new branch of data to AI engineering is coming into picture. We'll talk about that, what is the AI engineering is all about. Because now focus is shifting more from data engineering to AI engineering, where a lot of capabilities is being built using AI, right? So I talk about like Gen AI powered metadata management, what you need, like, So if you see in metadata, I think there are a lot of product outside market also, and I have seen from the companies, but ideally you need a metadata discovery to happen properly. Like you have, let's say, a lot of data coming from different systems, like from MySQL to Postgres to your NoSQL to your file systems to anything else, right? Now, the problem, like, and if you are a company like Walmart or JP Morgan or any other companies, there is a huge set of data that is getting generated, right? Now, how do you have algorithms to basically scan those data systems and make sure that, like, your metadata is updated and with the meaningful insight to it, right? So when I was in Walmart, there was a big team called data stewards whose job was to just scan the data and just put the meaningful name to that data, right? Now, with the Gen AI coming into picture, obviously the data stewards is required, but a lot of plumbing work, this looking into table and column, you can say what is there. And then it has the contextual data to it, right? So we can automatically discover the data, scan through that, and create all those, like the metadata could be technical, operational, or business metadata, right? So it requires like, so data tagging is one of the important part, right? How you can, do that. And the classification of your data, right? This is another problem, like if you are going to scale, right? How do you enrich your data, like say whether it's classifying in the sense either sensitive data. I work with the healthcare system, so there are a lot of PHI data coming into picture, right? Like let's say your diagnostic report comes from ThyroCare, you are uploading your prescriptions. So there are a lot of data that comes into systems, and we have to automatically classify because we have millions of such data, right? And anywhere in the systems, if you have those things, then you have to classify and say that which data is done. GenAI help us on some part of it. Still, this is a problem because once you try to classify your data, like you have to scan the data, right? And your cost may get increased, so there could be some accuracy on problems, right? Then I talk about data lineage part. So data lineage, another problem that we have from end source system to your data lake. There is a lot of, metadata get generated, and how do you stitch, like from this table, this column is transformed from that different table and different columns, right? And if you have multiple layer of transformation, you can think your life is going to be hell. So how do you make sure that taking those instrumentation by AI agents and basically stitch together so that there is accuracy on it and it is more reliable also. So, and then one part of we work in a lot of search and recommendation systems, right? And this, let's say you do a search in PharmEasy app, right? And the search result did not come, right? And there is a lot of contextual metadata that has come, like which user, what time, when, and where, right? And so these are the contextual data sets which we can join and get the meaningful insight to the business that this could have been some problem. So we have been playing with this metadata generations using AI and lot, and it has helped us in a big way. Okay. Sorry. Okay. Now I was talking about one other capability that we have been investing on, Text-to-SQL. So just to say the summary, what is a Text-to-SQL is like, all of you must be knowing it, but it's just a plain English you write, and it gives you the data, right? Still it is happening that you raise a request to analytics. So business folks raise a request to analytics. He writes a SQL. It's validate the SQL, then execute the SQL, and then it gives it. Like during this time, it takes 2 to 3 days, right? No, because somebody has to, and there is a back and forth. Maybe the business person didn't ask that question, he has generated something else. Then again, he has to go and correct back his SQL and give it back, right? It is very common problem everywhere. What we have been doing it, and we are piloting this with different teams, and making sure, all those questions that, business has a frequent asked questions or any other questions that come related to data, is in plain English format, right? Like, I just give an example, show me a total sales of top 5 product in last 7 days by region, right? And they'll just provide that, and they will get the data, right? And we have been exposing a lot of chatbot interface where they can just try to do that. Obviously, the governance process has been inbuilt because we don't want right persons to have right access to data, because this Text-to-SQL can be abused. So maybe we make sure that all the governance process and everything is taken care, right? So that's the another area that we have been heavily investing. And I'd like to show demo, but I think it's not working. Another problem that I talk about the synthetic data, right? So synthetic data, as you know, right? You can mimic your problems, like all your data, whatever could be, right? It could be. I give an example, a bank wants to generate a credit card transactions, right? He cannot create a credit card transaction just on the fly. So maybe with the synthetic data, he can use those credit card, fictitious credit card with that validation inbuilt and create a customer records on top of it, right? Without using the actual customer records, because there could be a lot of challenges on accessing those PII information that that has. Like, so synthetic data has been helping us. Like in our case also, like we have a lot of prescription, test report, and there are different variation of test report, right? So without actually getting the test report, we basically, let's say you go for HbA1c or any other test parameters, we know these are the parameters, this could be the actual range, and we generate to see how our, all our analytics pipelines works on that, right? So, and then you don't require a real data. Once the real data comes, everything should work if you have synthesized your data properly, right? Now, last, I wanted to talk about the AI engineering, right? Which again, we have extended our team, which is data teams, to now AI engineering team, which basically, like, we have, as you know, all of you know, there is a LLM models or generative AI models, and then you have the models which basically, like, all the workflow or API that is built on top of it, right? Like, let's say I talk about text-to-SQL, right? So think about like text-to-SQL, there is a LLM for it, but for like, let's say user gives a plain English language, right? And it has to finally show a dashboard or a report data to him. In between, it's not just the LLM that does the job. There's a lot of work that have, first the request has to go through a REST API endpoint, and that REST endpoint will call your LLM models. It could, maybe in our case, we are using, let's say, Gemini or any of the other things. You can use ChatGPT. But a lot of prompt has to be provided, right? There's a prompt engineering part of it, right? Because text-to-SQL, finally, how it works, that if you show those metadata has to be stitched together in the background, and that data basically finally converts to a SQL. So let's say I say cells, that cells has to be going to a corresponding tables, right? And then that table has reference to it. So all of this has a lot of engineering overhead, I could say, right? And unless you take care of that, even how powerful your LLM is there, that is not going to work. Like, and the pipeline aspect of this, like, so I have, let's say, text-to-SQL, but it is as good as your data set as the end, right? So let's say data model is that. So we make sure that quality of those data on which the text-to-SQL runs is very good, right? So there is a lot of data engineering comes into that. Then we have RAG and agents, right? So agenting is like we have used some of the open source agents, and we build on top of that a chatbot, which is basically like, let's say, a customer support comes into picture, right? So, and this is the famous use case, like, usually customer support comes and say that where is my order, right? And that order basically like shows that you're stuck into this place, right? And they have the follow-up question on it, right? Right now, if you go to our dashboard, it will just show that your order is shipped or not shipped, right? But if you have more contextual question, is that when it was shipped, why it was delayed, it can answer, this chatbot can answer those questions. And that's why like all this like AI engineering is helping us, right? Whatever AI platform is helping. So obviously we use Gemini, but all these AI platforms is helping us to make sure that all the plumbing works has to be done to work with the chatbot is done, right? Then same thing with we have our own vector DB, like all the and that has to be managed with all the by the data engineers to make sure that they are scalable, right? We do like a lot of fine tuning. So obviously we have and inference optimizations, like you have a pre-trained on AI model like ChatGPT or your Gemini, but we do a lot of fine tuning on customization on that. And similarly on the, let's say, initially when we started using the Gemini model, it was very small, right? But very latency was very, you fire a query, it goes and then come back with a lot of things because the context to them is not correct, right? So we have contextualized and make sure that they are fine-tuned, and we did the inference optimization also. Once it is, inference optimization is nothing but like you basically get the data in a format and then make sure that it has the low latency to serve to your API that is asking for, right? So, and then we build all these AI observability and explainability platform, which basically means like, let's say, I just talk about the same text-to-SQL use case, right? Now, it gives you data, but it doesn't explain where this data has come from, right? So we have built that explainability. User can go and see this data is belong to this table, or maybe it gives the SQL also for a technical users, but it also gives the reasoning of that, right? How this data has been derived. So if I have a ThyroCare cells, it says that from the ThyroCare, from this region to that region, I have joined this table to give this data, right? So it gives us complete explainability so that the user has trust on data, whether it's great, good or bad, right? And that's why this platform that what we call it AI engineering or AI platform has been helping us. I think this was the last slide, right? So in summary, I think I talked about from the source to destination, right? I mean, when we started, it was more like traditional data platform and things like that, right? Because as I said, like, we first build those platforms. Now, with the Gen AI capabilities, like we have plug-in everywhere, right? Right from data observability platform, which is detecting your pipeline failures, to remediating those failures. Now, putting the data in a way that you can have more resilient system. It like if something fails, we have more resiliency to take care of it. And finally, on the consumption side, we have using the text-to-SQL to make sure that our business has integrated experience and more self-service experience rather than depending on analytics. So right from ingestion to insight generations to operational intelligence, we have been using AI. I'm happy to have more deep dive conversation if you guys have any. So next, any questions?